Hello, everyone. Welcome to section 3.3. We are going to be talking about dividing polynomials. This is a very important section. Dividing polynomials will pop back up again and again. We will be using these skills quite heavily in future sections. So 10 out of 10 recommend that you do your best to try to get a handle on it. Dividing polynomials can be sticky and hard, and try to get a grasp on it now so you don't try to play catch up later. Just a little heads up, because this will show up again. The good news is that dividing polynomials, the same idea as dividing numbers. So let's say we were in number land and we want to divide like 42 by 5. If we would go ahead and do the division, the arithmetic, whatever, we'd see that it would be 8 plus a remainder of 2/5, right? And just some anatomy. This is called the dividend. Right there, that's the top number, and the divisor is the one on the bottom. And then on the other side of the equal sign, we have the quotient, and then the remainder. The remainder is the number on top. It's the 2, not the 2/5. Okay. So dividing polynomials looks very similar. So for example, if we wanted to divide like 6x squared minus like 26x plus 12. Let's say we wanted to divide that by like x minus 4. It turns out that we can write this as 6x minus 2 plus 4 over x minus 4. So here, the same words apply. That right there is the dividend. The divisor is the polynomial on the bottom. The quotient is what pops out, and then the remainder is what's left over. Okay, so there are two main ways to divide polynomials. We're going to go over the main way first, and then I'll talk about like a secondary way that you can use sometimes that works a little bit quicker than long division, which is what we'll cover first. But first, yeah, let's do long division. So as with most things in math, this is best seen through an example. So let's go ahead and do one. Let's divide x squared minus 3x plus 7. Let's divide that by x minus 2. So this problem right here, fairly straightforward. We just have a quadratic, a degree 2 polynomial on the top. We have a linear degree 1 polynomial on the bottom. So this division will be fairly straightforward. So the way we do this is we take that divisor and we write it to the left of a dividing bar sign. And then we take that dividend and we write it underneath there like that. Okay, so now we get started. So when we're doing this, we're going to be looking at this term that I'm going to circle in blue quite a bit. And to start off, we're going to take a look at the first term in the dividend. And we're going to ask, what can we multiply the thing in the blue circle by to get to the yellow thing? So like this is an x and this is an x squared. So the thing in the blue circle is missing a factor of x. So we write that up there like that. And then we say, okay, we take that x and we multiply it by the terms in that divisor. And we write them underneath the dividend. So x times x in that blue circle, that gives us an x squared. And then x times minus 2 is a minus 2x. And then we just put that thing in parentheses and we subtract it away from the thing on the top. So x squared minus x squared, that's going to be a 0. This first term, whenever you do this subtraction, should always be a 0 if you did the first step correctly. Okay, and then the next term is a minus 3x. Don't forget to distribute this minus sign here. into there. So that's actually a plus 2x. So minus 3x plus 2x, that just pops out minus x. So that was one step of the division. And now we do the next one, same kind of thing. So now instead of looking at the x squared, we're going to do this term now. And we ask, okay, what can we multiply the thing in the blue circle by to get to the thing in this new yellow box? So the blue circle is just an x, and the yellow box we're looking at now is a negative x. So we need a minus 1. So we'll put that up here. So we have an x minus 1 up there on top. Okay, so now we take that minus 1 and we multiply it by the terms right there. Same thing as last time. So minus 1 times x, that's going to give us a negative x. And then a minus 1 times negative 2, that's going to be positive 2. And now to do the subtraction, we need to drop this term down to 7 right here. So we bring that down there. And then we go ahead, put our parentheses, and do that subtraction. Again, we see that minus x, that's positive x. And then you add that to negative x, we get a 0. So we did that step correctly. That's good news. It should always be a 0. And then that right there, so that's going to be minus 2. So 7 minus 2 is 5. So plus 5 right there. Now we stop. We stop because 5 doesn't have any x's. If we try to do this box in yellow step and we ask, okay, so what can we multiply this x by to get to 5? There's nothing. We would have to take away things to get there. So the process terminates. And the 5 is actually our remainder. And so the answer here is that when we did this division, this x squared minus 3x plus 7 all over x minus 1. The way we can write this is we take what we found up here on the top, this x minus 1. That's our quotient. And then our remainder is 5. And in order to make this equal, we have to put the remainder over what we were dividing by. So we have to write 5 over x minus 2. There you go. That's your first polynomial division. It's not so bad. It's just a lot of steps to keep track of. But there are a couple checks that you can do. The main one is making sure that that thing pops out as 0 every time. That's the main thing you should be looking for. Okay, let's look at a much more difficult example, or one rather that just has more steps. So let's go ahead and divide 2x to the 5th minus 7x to the 4th minus 13, and we're going to divide that by 4x squared minus 6x plus 8. Okay, so let's go ahead and write these out. So our divisor over here, so we've got 4x squared minus 6x plus 8. That looks good. And then we write our dividend underneath the bar, so 2x to the 5th minus 7x to the 4th minus 13. Oh, sorry, I almost made a dumb mistake. So when you're writing down the divisor here, if you're missing powers of x, so see how it goes from x to the 5th to x to the 4th, and there's no x, it's x to the 0. We're going to fill in those missing spots with a plus 0 times x to the 3rd, plus 0 times x to the 2nd, plus 0 times x minus 13. And that might seem kind of silly and redundant. The reason we do that is so that all the columns kind of line up when we do that drop down thing. It makes it much nicer to keep track of things. This is the way you should be doing it. Otherwise, you will probably get lost. I would definitely get lost. So let's go ahead and do this division. Let's go ahead and get our circles going. So blue circle is that term right there. And then the first thing we're going to be looking at is this one right here. So we ask, what can we multiply the thing in the blue circle by to get to the yellow square? So the blue circle's got a 4, and the yellow square's got a 2. So we're probably going to need a 1/2 here, right? So that 1/2 will multiply by the 4 to get a 2. And then we're missing 3 powers of x, so we need next to the 3rd. Okay, so now we multiply that by all the terms. and we get 1/2 x cubed times 4x squared. That's going to give us a 2x to the 5th. That's looking good. And then the next one we multiply, we get a minus 3x to the 4th. And then 1/2 x cubed times 8, that's going to pop out a plus 4x cubed. And then put parentheses around that and subtract it away. Okay, those match up, they subtract away, that's 0, that's good news. We want to see that. Okay, don't forget to distribute that negative sign. So this is a plus 3x to the 4th minus 7x to the 4th. So that's going to give us a minus 4x to the 4th. And then minus 4x cubed, and then that's just a fancy 0 up there. So we just get minus 4x cubed. And then we drop down this term just to be safe. It's just 0, but it's good to kind of keep a placeholder mentally. Okay, so now we do the same thing, but now we look at this one. This one has a minus 4x to the 4th. So, and then the blue circle has a 4x squared. So there's a difference of like a minus 1. So we're going to need a minus 1, and then we're going to need 2 powers of x to make up that. So we'll get a minus x squared. And then we go ahead and multiply that by our terms over there. And then I think what you'll find is we get a minus 4x to the 4th. That's looking good. And then a plus 6x cubed and a minus 8x squared. Slap parentheses around that, subtract away. That cancels out, that goes to 0, that's good. And then a minus 4x cubed minus 6x cubed, that's going to be a minus 10x cubed. And then a 0 plus 8x squared, sorry, that's going to give us plus 8x squared. Drop down that 0 term now, plus 0 times x. And then we do the same thing again. So now we have a minus 10x cubed. So the thing in the blue circle is a 4x squared. We need to turn that 4, multiply something by that 4 to get it to be minus 10. I think what will work is a minus 5 halves. And then the thing in the blue circle is an x squared. The thing in the yellow box is an x cubed, and we need 1 power of x to make up that difference. Okay, now we do that same multiplying that by the terms there. And I think what you'll find is we get a minus 10x cubed. That's looking good. Plus 15x squared minus 20x. Slap parentheses around that, subtract it away. We get a 0 again. That's good news. And then we get a, minus 7x squared plus 20x. And then we drop down that minus 13. That was a little long. Minus 13. There we go. All right, same thing again. Look at this term. It looks like we're going to need to multiply something by that 4 to get to a minus 7. I think we need a minus 7/4. So if you multiply negative 7/4 by 4, you get a minus 7. So that looks good. And then we take that minus 7/4 and multiply it by the divisor. And let's see, I think we'll get minus 7x squared plus, and then this is 21 halves x plus 14. Oh no, sorry, that is a minus 14. My bad. Go. Same thing, parentheses, subtracted away. That's a 0. Excellent, excellent. And I think this is going to be plus 19 over 2x plus 1. Okay, so now the process stops. The process stops because down here we have an x, and up here we have an x squared. And whenever you're the thing that you're working with down here drops a power below your divisor, process terminates, that's going to be your remainder. So that's important enough that I'm going to go ahead and write that down for you. So now we stop. Because we have a remainder of degree 1 That's this thing in green right here. And that is less than the degree of our divisor, which was 2. Okay, so our process stops. And so our final answer for this problem is 2x to the 5th minus 7x to the 4th minus 13 all over 4x squared minus 6x plus 8. And we can write down what we had up top here that we found. That will be our quotient. So 1/2 x to the 3rd minus x squared minus 5/2 x minus 7/4. And then we have to write down our remainder. So that was 19/2 x plus 1. And then we have to put it over our divisor, which was 4x squared minus 6x plus 8. And that is the full answer for polynomial long division. Okay, let's go ahead and take a look at one more example because this stuff's pretty important. And it can get kind of weird sometimes. So let's do one more. Let's divide x to the 6th plus x to the 4th plus x squared plus 1. Let's divide that by x squared plus 1. Okay, so same deal as usual. I'm going to go ahead and write our divisor. And just to keep it consistent, I'm going to keep that notation. I'm going to leave that 0 times x there plus 1. It won't have actually changing thing, but just so we can keep all our ducks in a row. And then x to the 6th plus, we're missing an x to the 5th power, so we need 1, plus x to the 4th, and we're missing an x to the 3rd power, so we need to put 1 in there, plus x squared. And then, of course, we're missing another thing, just the x term, 0 times x plus 1. Okay, move that over a little bit. There we go. Okay. So this is what we're going to be taking a close look at. Our first candidate up is this x to the 6th. So we want to ask, what can we multiply the thing in the blue circle by to get that x to the 6th? It's pretty straightforward. It's going to be an x to the 4th. Then we multiply the x to the 4th by our divisor, and we get x to the 6th plus 0x to the 5th plus x to the 4th. Subtract that away, and then we get 0 here. That's good. That's 0 minus 0. That's just 0. And then we get x to the 4th minus x to the 4th. Oh, another 0. Okay. Sometimes that happens. And then we'll drop down the next term. Oh, but that's just 0 again. Okay. So then we drop down the next term. And now we have x squared. Okay. That's not 0. We can work with that. So now we ask, what can we multiply x squared by to get x squared? Again, pretty straightforward. Pretty sure the answer is just 1. And we multiply 1 by our divisor. And don't forget to drop down these terms so that we can subtract appropriately. So if we do 1 times x squared, that's just x squared, plus 0 times x, and then 1 times 1 is 1. Parentheses, subtract it away. All right, x squared minus x squared, that's 0. 0 minus 0 is still just 0, and then 1 minus 1 is 0 again. There's a lot of zeros in this problem. Okay, now you'd be like, we've got all zeros. We don't have anything else to drop down. Now, if you remember from like number long division, this means that you don't have any remainder. So the answer is, so we were dividing x to the 6th plus x to the 4th plus x squared plus 1 over x squared plus 1. So our answer is just going to be our quotient, x to the 4th plus 1. No remainder. Okay. So this can happen. This will happen. Don't worry. You still did it right. The zeros just make it easier to do. Just make the problem quicker. All right. So now let's talk about the other way that people will sometimes divide polynomials. This is called synthetic division. I'm going to keep this pretty short because, quite frankly, I'm not the biggest fan of synthetic division because long division will always work. Sometimes it's longer and it's more work and it's more writing, but long division always works. Synthetic division only works in certain cases. So the pros of synthetic division is that it works faster. It's very clean and neat. The cons is that it only works when you're dividing by a linear factor. So some degree 1 thing. Okay. So let's go ahead and do an example. Let's go ahead and divide 2x to the third minus 7x squared plus 5. And we'll divide that by x minus 3. So here's how we set up synthetic division. We're going to use a flipped dividing bar. We're also going to have a bar down here. Okay, so now we take this number right here, this minus 3, we flip the sign so it becomes a positive 3 and we write it here. So flip the sign. Okay, and then for in here, what we do is we take the coefficients off of our dividend and we write them in there. Okay, and make sure that you notice there's no x term here, so we're going to write a 0 for that coefficient. So the x cubed term has a 2, x squared has a minus 7, x is 0, and then a 5. Okay, so here's how we do synthetic division. The first step is we're going to drop down this 2. Just right there like that. Okay, and then we're going to take the 3, we're going to multiply it by the 2 and pop it up there. So 2 times 3 is 6, so we're going to write a 6 there. And now what we do is we do minus 7 plus 6, that's going to be minus 1, and we write it there. And then we do the same thing again for this minus 1 as we did with the 2. We take 3 and multiply by it. So 3 minus 1 is negative 3. We take that and we write it right here. Minus 3. 0 minus 3 is still minus 3, so we just have minus 3 there. And then again, 3 times negative 3, that's a negative 9. We write that up here. And then 5 minus 9 is negative 4. And that's actually it. We're just done. So it is much faster. And so now we just need to translate what we've written down into like something that actually kind of makes more sense. So the first whatever numbers are going to be your quotient. And this is your remainder. And so the answer that we can divine from this is that if we divide 2x to the third minus 7x squared plus 5 by x minus 3, the answer is going to be 2x squared, that's the 2 up there, minus x, that's the minus 1, or sorry, minus x, that's the minus 1, and then minus 3 from the negative 3, and then plus the negative 4 over our divisor, which was x minus 3. Okay, if that was confusing to you, don't worry. You don't have to know synthetic division. As long as you are good at long division, that's perfectly fine. I won't ever ask you to explicitly do synthetic division, mostly because I'm not the biggest fan of it. And also just because long division will always work. So, all right. So that's it for polynomial division. But before we go, we need to talk about some special rules / why it's useful. So why division is useful. And we'll see a bunch of different uses for polynomial division in the future, but there are two that we can talk about right now that we should and they're good ideas, and they will keep popping up. So the first one, there are two. The first one here is called the remainder theorem. The remainder theorem says if you have some polynomial, we'll call it p of x, p for polynomial, and we divide it by some linear factor. So remember, that means degree 1 polynomial. Let's call this degree 1 polynomial, let's call it just x minus c. The remainder of that division will always be equal to plugging in that c into your polynomial. So for example, earlier we did the division x squared minus 3x plus 7 divided by x minus 2. That was our first example. So we saw the remainder is 5. So let's check to see if this remainder theorem works. So here, our c is 2. Note that there's like a negative sign here. So there's a negative sign there. So it's just going to be 2. So our c is 2. If we plug in 2 to the top thing, we have like a 2 squared minus 3 times 2 plus 7. That's going to just be like 4 minus 6 plus 7. And oh, look at that, it's 5. Aha, it works. So this is a pretty cool little trick. The second rule is a little more important, and I use it all the time. It will come up again. So the second rule is the factor theorem. So the factor theorem says c is a 0, a root of a polynomial called p of x, if and only if, and I'll explain what that means in just a sec, x minus c, so that linear degree 1 polynomial, is a factor of p of x. So this rule's a little more dense, especially because it's got that weird if and only if in it. You remember from like high school geometry, and if and only if is a biconditional. That's just a fancy word for it. But what this is saying is that if you have some root of a polynomial, then x minus c is, so if your root c, x minus c is going to be a factor of it. And if x minus c is a factor of your polynomial, then c is going to be a root. So it goes both ways. So if you have c and you know it's a 0, we know that x minus c is a factor. And if we have that x minus c is a factor, c is going to be a 0. So it goes both ways. So this might make a little more sense if you look at like an example. So I didn't do this example in this lecture, but if you were to divide these two things together, 3x squared minus 2x minus 8, you divide it by x minus 2, this is going to pop out 3x plus 4. So notice there's no remainder. Okay. What this is saying, since there is no remainder, x minus 2 is a factor of 3x squared minus 2x minus 8. So what that means is that we can take 3x squared minus 2x minus 8, and we can write it as our quotient times our divisor. We just factored that polynomial. So that's what that means to be a factor of it. And what the factor theorem says is that since it's a factor, our c, which in this case is 2, is a root of it, a root of that thing up there. So let's just double check that, just so we can convince ourselves. So let's just plug in 2. And if it is a root, we should get 0. So if we plug in 2 for x, we get 3 times 2 squared minus 2 times 2 minus 8. That's going to be 2 times 2 is 4. 4 times 3 is 12. So we've got 12 minus 4 minus 8. And oh, look at that. It is 0. 2 is a root. Okay, this is a pretty deep idea. Give it some time to sink in. It will pop up again in different contexts. And over time, as we get to use it more and more, this factor theorem idea will make more sense. So don't worry if you don't fully get it yet. It's okay. This will start saturating later. But make sure you practice long division. That will be important. Anyway, good luck on your homework. And if you have any questions, I'll be in office hours.